Hello, I'm James Wahlberg, and I'm going to show you how to predict the products of amide synthesis reactions. Let's take a look. The first thing to understand about predicting these products is to know that amides can be synthesized from many different carboxylic acid derivatives. The important point is that the carboxylic acid derivative has a leaving group that is a better leaving group than the amine would be. So the amine ends up staying and the other substituent ends up leaving the carboxylic acid derivative. A nice example of that would be an acyl halide. The halide ion is a very good leaving group, and therefore it can be displaced by the amine that will come in and form the amide. Also keep in mind that if the amine group is part of the same molecule as the carboxylic acid group, then we'll end up with a cyclic amide. And these are called lactams. Now, this works when we have either the delta or gamma amino acids. And that means that the amine group is either 4 or 5 carbons away from the carboxy group, but in the same molecule. When we cyclize and form a lactam out of these, the delta will give us a 5-membered ring, and the gamma will give us a 6-membered ring. And 5 and 6-membered carbon rings are fairly stable structures. So let's take a look at a couple of examples, and I'll show you how to apply things you already know to predict the products of amide synthesis reactions. In this first example, we'll take a look at the reaction between ethanoic anhydride and normal propamine. If you look for which functional groups will act as nucleophile and as electrophile, as we do in all these reactions, you'll see pretty quickly that the nitrogen on the amine is going to act as the nucleophile, and it will attack the electrophile of one of these carbons that's bearing the carbonyl oxygen. When that happens, the bond gets displaced over to the oxygen, and that entire molecule of ethanoic acid will act as the leaving group. When that happens, we get the substituted ethanoic acid, and the leaving group, as I said, is ethanoic acid itself. So you can see the components in the product. Here is our amine, and here is half of the ethanoic anhydride. What we formed then again is ethanoic acid, and the molecule that we've synthesized is N-propyl ethanamide. Let's look at one more example. Here we have 5-aminopentanoic acid. Notice that that is a molecule with an amine group 5, or in the delta position, away from the carboxylic acid group. So we should be expecting that we could form a lactam here. If we provide some heat, we can see that there is potential for intramolecular interaction to form a cyclic compound. The nitrogen is going to act as the electrophile and attack that carbon. Water will be displaced as the leaving group, and we will in fact form the lactam. So there's really not a whole lot of new information that you need to think of in terms of predicting the products of amide synthesis. If you keep in mind the properties of carboxylic acid derivatives, identify the nucleophile, identify the electrophile and the leaving group, and you'll be able to predict accurately and quickly the products of amide synthesis reactions. Good luck in your study of organic chemistry. I'll see you in another video.